Hi, I'm Paul Kyogan from GKTuition, and in this video I want to talk to you about probability. Now the question that I've chosen to go through here is 2018 Paper 2 Question 1. In this question we're told that 2 dice are rolled, and when the dice are rolled the results are added together. What we've been given in the diagram is a sample space, or in other words just a list of all the possible outcomes. Along the red here from 1 to 6, that's what I could get in the first dice, and along the side here in red 1 to 6 is what I could get in the other dice. And the black numbers here are all if we add each figure together. So for example, if I got a 3 on this dice and a 2 on this dice, it would add up to 5. There's been 6 of them that haven't been filled, so to get the marks for A part 1 we just need to fill them in. 6 and 1 gives me 7, and 5 and 2 gives me 7. This one corresponds to 4 and 3, which is 7. Then beside it is 4 and 4, which is 8. Then down here I have 5 plus 5, which is 10. And on the bottom I have 6 plus 6, which is 12. That's all you need to do to get the marks for A part 1. Now let's look at A part 2. In A part 2, it's asked me to work out the probability of getting a 7 or an 11. So let's just work that out. So the number of 7s or 11s in this case, well, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8. If I add up all the 7s and the 11s, they add up to 8. So I can say, remember in probability, it's the number of favourable outcomes over the total number of outcomes. The favourable outcomes in this case is 8. There's 8 7s or 11s, and the total possible number of outcomes, there's 6 columns across and 6 rows down, so 6 by 6, there's 36 possible outcomes. So the probability of getting a 7 or an 11 is 8 over 36, but whenever you're dealing with probability, you have to write your answer in its simplest form. You could divide both of these numbers by 4. If you weren't 100% sure on this, you could just plug it into your calculator. But if you plug it into your calculator, the final answer in that case, it works out as 2 over 9. Now in A part 3, we've been asked to work out the probability of getting a prime number. Now you should need to remember that getting prime numbers are any numbers that have 2 divisors. So for example, 7 is a prime number because the only number that divides into 7 is 7 and 1. So it's got 2 divisors, itself and 1. Happy days, it's a prime number. So let's just start off by recording what all the prime numbers are. First of all, a very common mistake, you need to realize that 2 is a prime number. 2 is the only even number that is also prime, because there's only 2 numbers that divide into 2, itself and 1. 3 is also a prime number, so happy days. 4 is not, but 5 is a prime number because only 5 and 1 divide into 5. 6 is not a prime number, 7 is, but 8 isn't, 9 isn't, 10 isn't, 11 is a prime number, but 12 isn't a prime number. So let's just add them all up now. I want to include the 11s, the 7s, the 5s, the 3s and the 2s. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 prime numbers in my sample space. So the probability of getting a prime number works out as 15 over 36. Now if you plug 15 over 36 into your calculator in this case, your final answer is going to work out as 5 over 12. And you get the full marks for that here. Okay, in the final part of question 1, we're told that a car dealership has 30 cars. That 18 of them are Ford and 12 of them are Renault. Of the Ford cars, 7 are red and 11 are not red. Of the Renault cars, 4 are red and 8 of them aren't red. We're asked, if we just select a car at random, what is the probability you would select a car that is either a Ford car or a red car? I want you to realize that it's irrelevant how many of the Ford cars are red. That's only just throwing you off. I want to know what are the chances that I either take a Ford car or a car that's not red. So the only cars that I don't want to include are the 4 red Renault cars. They're the only ones I don't want to include. I just want the probability that I either take one of these 18 cars or one of these 8 Renault cars that aren't red. So if I just add that up, there's 18 cars that are Ford cars, and then there's another 8 cars that aren't red. 18 plus 8 means the total number of cars they're talking about here is 26. I want to know what is the probability that I either take one of these or one of these, but make sure that I don't take a red Renault car. There's 30 cars in total, so the chances of that is just 26 over 30, which if you simplify it fully, in probability it's 13 over 15. That's the chances that you will either pick a Ford car or a car that's not red.